All right, let's dive into AI today, specifically small language models, the kind of AI that's super helpful but can also run on like phones and stuff. Imagine having a crazy powerful AI right in your pocket.
Yeah, it's really cool. For a while, research was all about making these massive AI models. But now, things are shifting, and we're seeing these smaller models becoming just as good.
That's where SmolLM2 comes in, right? It's this new small language model, and we're going to break down the research paper all about it today.
Yeah, SmolLM2 is super interesting. It's small, only 1.7 billion parameters, but it's still incredibly powerful.
Okay, hold on. ELA 5, what are parameters?
Haha, good question. Think of parameters as like the settings inside the AI. They control how it learns and processes info. More parameters means more complexity, but also it needs way more computing power.
So SmolLM2 is like small and powerful, I get it. The research paper really digs into the data they used to train SmolLM2. Why is that so important, especially for a small model?
It's all about efficiency with these small models. They have a limited capacity to learn, so the data has to be, really high quality. Like if you were teaching a student, you'd want to make sure they're learning the core concepts first.
Quality over quantity when training a small model.
Exactly. And that's what the researchers behind SmolLM2 did. They used a multi-stage training process. They fed the model a ridiculous amount of data, 11 trillion tokens. But they did it super strategically.
Whoa, 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 back up. 11 trillion tokens. Is that like a lot?
Haha, yeah, it's a lot. Imagine reading every single book in the Library of Congress, like hundreds of times. That's 11 trillion tokens.
Oh, wow. Okay, that's a ton. But before we dive into how they trained it, why even focus on small models when we have these massive ones already?
That's a good question. The big models, they need a ton of power and special hardware to run. Not many people have access to that.
So it's about making AI accessible. I get it.
Exactly. Smaller models like SmolLM2 can run on almost anything, your phone, your laptop.
Oh, wow, that's amazing. So small models could mean like everyone can have access to powerful AI.
That's the goal. And coming back to the training, they didn't just feed the model all 11 trillion tokens all at once. It was done in specific stages.
Okay, interesting. What was the reasoning behind that?
So there were four main principles they followed. First, they kept a close eye on how well the model was learning.
So like giving it tests along the way.
Yeah, exactly. They used these things called benchmarks to test it. And based on the results, they'd adjust what data they were feeding it.
Ah, so they were constantly making sure it was learning correctly.
Yep. Second, they saved the best data for last. Things like math and coding data.
That makes sense. Got to make sure it gets the basics down first.
Yep. The third principle was all about when they introduced certain data, they didn't want moderately sized data sets to get lost in the mix.
So they waited for the right time to introduce it.
Exactly. And lastly, they made sure the model wasn't seeing the same data over and over again.
No repetition. I guess that makes sure it's actually learning the information and not just memorizing it.
Exactly.
So what kind of data are we talking about here? What did they feed small M to?
Well, a lot of it was English web data. Two big data sets, actually.
Okay, what were they?
One was called FineWeb Edu, 1.3 trillion tokens, all about educational stuff, like textbooks and articles.
So building a solid base of knowledge right from the start.
Exactly. The second one, DCLM, was more casual, 3.8 trillion tokens. It had things like text from Reddit, more conversational stuff.
So they wanted to make sure it understood how people talk, not just formal stuff.
Yep, exactly. They wanted SmolLM2 to be well-rounded.
That makes sense, but I'm guessing they used more than just language data, right?
You bet. They also use specialized data for things like math and coding.
Okay, now I'm really interested. Let's talk about math first. I don't often hear about AI learning math.
Well, math is important if an AI is going to understand the world. They were very intentional about the math data. They actually created a whole new data set for it called FineMath. They weren't happy with the existing math data sets. They were either too small or didn't focus on the right stuff, step-by-step reasoning and problem solving.
So they built their own.
They did. They know how important it was. This new data set, FineMath, it's got a whopping 54 billion tokens of math stuff. It focuses on logical deductions, proofs, and problem-solving strategies.
Like a math boot camp for small LM2. Did it help?
Oh yeah, SmolLM2 got really good at math after training on FineMath, solving hard problems, understanding tricky concepts. It could even come up with its own mathematical proofs.
Really? That's wild. So clearly the right data makes a big difference. What about the coding stuff?
They used a dataset called StackEdu. It's a filtered version of this other dataset, StarCoder2 data. StackEdu has a bunch of well-documented and educational code.
So instead of just random code, it's learning from good code.
Yeah, exactly. Like giving a new programmer a library of the best code to learn from.
Makes sense. So small LM2 learned to code too.
After training on StackEdu, it picked up the basics of programming, understanding different coding languages, even generating its own code.
Wow, the multi-stage training is really impressive. But the training doesn't end there, right?
Right, there's more. Instruction tuning and then alignment, also called preference learning.
Okay, break that down for me. What's instruction tuning?
Think about it this way. You've taught someone a bunch of stuff. Now you want them to use that knowledge. That's instruction tuning. teaching the model to follow instructions, give helpful and informative responses.
So putting all that knowledge into action.
Yeah, exactly. And they made a new data set for this called Smalltalk.
Small talk, I like it. What kind of instructions are in there?
All sorts, from easy ones like translate this to more complex ones like write a poem about the universe. They wanted to teach it how to respond to all kinds of instructions.
So small talk is like a giant how-to manual for SmolLM2. What about alignment or preference learning?
Alignment is all about good and bad responses, teaching the model what's helpful, appropriate.
So it's not just giving information, but understanding how to give it.
Yeah, like understanding the nuances of human communication.
That's important. We want AI to be smart, but also responsible. So after all this training, how did SmolLM2 do?
It did great. It aced a bunch of benchmarks, especially in knowledge, reasoning, math, and code. It even beat some bigger models on certain tasks.
Wow, so size isn't everything. What does this mean for AI in the future?
I think it shows that data and training methods are super important. You don't always need a huge model to get great results.
It's about working smarter, not harder.
Right, and this is a big deal for accessibility. As these smaller models get better, everyone could have their own AI assistant.
That would be incredible. Having an AI in your pocket that can help with anything.
It's coming, and SmolLM2 is proof of that.
This deep dive has been amazing. I've learned a lot about how powerful these small models can be. But before we go, where can people learn more about SmolLM2? Can they try it out?
The researchers made SmolLM2 publicly available, along with the datasets they used.
That's awesome. Anyone can experiment with it, see how it works.
Yeah, and even help make it better. It's open source, so anyone can contribute.
That's really cool.
This kind of open collaboration is really driving AI forward.
I agree. It's exciting to see this technology being shared with everyone. This really changes how we think about AI. For so long, bigger was always better, but SmolLM2 proves that's not always the case.
Right. Innovation isn't just about size. It's about being smart and finding creative solutions. And yeah, the data is super important.
SmolLM2 shows that smaller models can be just as capable as long as they're trained the right way.
And that opens up so many possibilities. Powerful AI doesn't have to be limited to just big companies and labs anymore.
It could be available to everyone, developers, researchers, everyday users.
Exactly. That's what's so exciting about this.
This has been a really fascinating deep dive. I'm genuinely excited about the future of small language models like SmolLM2.
Me too. It challenges how we think about what AI can do, pushing the limits of both efficiency and performance.
It's amazing how a smaller model can sometimes even outperform the bigger ones.
It shows that there's always room for new ideas, even in a field as complex as AI.
Absolutely. So for our listeners who want to explore SmolLM2 themselves, where can they go?
The researchers made SmolLM2, and the datasets they use publicly available. It's all open source. Anyone can access it.
That's fantastic. So anyone can play around with SmolLM2 and see what it can do.
Yeah. And they can even help improve it. That's the beauty of open source.
It really is. It's amazing to see this kind of collaboration in the AI community.
This open approach is accelerating innovation in AI.
We'll definitely include links to those resources in the show notes so everyone can check out SmolLM2 for themselves. This deep dive has been a glimpse into a future where powerful AI is available to everyone.
Yeah, a future where AI is more than just a concept. It could be a helpful tool in our everyday lives.
This has been an incredible deep dive. Thanks for joining us on this journey into the world of SmolLM2. We hope you learned a lot, and we're excited to see what amazing things you do with this knowledge.
It's been a pleasure. Keep exploring, keep learning, and keep pushing the boundaries of what's possible.
Until next time, NE2OT.